Good morning.
Good morning. Good morning.
Later. Good morning, Mr. Tucker. How y'all doing?
Good morning. Good morning, sir. How's it going? How's it going? All right. Sorry, guys. I was looking for something. Okay. Cool.
This class get more slimmer and slimmer.
Yeah, it tends to happen, sir. I just spotty. Sometimes people come in and miss days, and then they can review the lectures. So I chalk it up to that. That's the best case scenario. People reviewing it on their own time. All right. So I hope everybody's doing all right. Hope everybody's doing good. We starting today with 17.5. All right, look at 17.5. And if we should have some time also, if anybody have any questions or anything. Let's go ahead and get the lecture out of the way.
Hey, Mr. Tucker.
Yes, sir.
So I got this Elian Martin Gay Algebra Foundation book, right?
Mm-hmm.
So if I go to 17.5 right now, because I ain't use this book for real.
Mm-hmm.
So if I was to find 17.5 right now, would this stuff be in it? So if I go you know what I'm saying?
Now, is that the class? That's not the class text though. That's what you're saying, right?
This is the one that was on the thing I needed to, this is on the list of things I need to buy.
Okay, yeah. If it's the class text, then it should be this. Now, don't forget also, if you can't find it, where's my stuff at? Yeah. So now if you were to go to the e-text contents in your, the math lab, all of these match up with that. So if I were to go to chapter 17, 17.5, hit e-text.
Ah, okay.
So yeah, it should pop up.
Okay.
There we go. Yep. So that's what we're looking at today.
All right.
Thank you. Yep. Not a problem.
Right there too. Right there.
Yes, sir.
1293. If anybody was looking for it, 1293.
All right. Thank you, sir. All right. So let's look at 17.5, rationalizing the denominators and numerators. So in the red, you see rationalizing denominator numerator means you want to remove the presence of the radical. Where's my pen? So you remove the presence of the radical. So if they ask you to rationalize the denominator, you're trying to remove the presence of a radical in your denominator. If they ask you to rationalize the numerator, you're trying to remove the presence of a radical in the numerator. So here we have square root of 2 over square root of 3. And if we want to rationalize the denominator, we are trying to get rid of the fact that we have square root of 3 in our denominator. So in green is the question you should be asking yourself. If you're trying to get rid of that square, you got to ask yourself, what can you multiply to 3 in order to turn it into a perfect square? I'll give you guys a chance to write that down. All right. So what can you multiply to 3 in order to turn to a perfect square? That's multiplying it by 3. That's what I have right here. 3 times 3 makes it a 9. So you can take the square root of 9. So that's what we do here. So you multiply top and bottom by the square root of 3. And so remember, whatever you do to the bottom, if you're dealing with a fraction, you have to do to the top as well. So square root of 3 times square root of 3 would be square root of 9. And so square root of 3 times square root of 2 will give you square root of 6. Square root of 9 is 3, and you leave the 6 under the radical because you cannot take the square root of that. So you see that removes the presence of the radical in our denominator. All right, any questions on that before we go to the next ones? All right, scrolling up. So next one, we're looking at 5 cubed root of 2. So this time it's the same thought process, but we're looking at the cube root. So you can see my question here, what can I multiply to 2 in order to turn it into a perfect cube? So I will multiply that 2 by 4. 2 times 4 give me 8. I can take the cube root of 8. So that's what we will multiply the top and bottom by. Cube root of 4. So that gives me on the bottom cube root of 8, and then on top 5 cube root of 4. I can take the cube root of 8, which is 2, and then that numerator just stays that way. There's nothing I can do with that. All right, any problems, any questions before we go to the next one? All right, next one, square root of 17x over 19y. Trying to rationalize our denominator. So just like before, we had the square root of 3, you multiply it times 3 in order to turn it into a perfect square. This time we have the square root of 19y. So we'll multiply top and bottom by 19y in order to turn it into a perfect square. And that's what I did right here. So 17 times 19 gives you 323, then xy. Bottom, 19 times 19, it's whatever that is. I just ended up just leaving it as 19, but we know it's 19 squared. Same thing with y squared. And taking the square root of that will just leave us with 19y. So you don't necessarily have to go all the way and write what 19 times 19 is. The bottom line is, 19 times 19 is 19 squared. Taking the square root of that will leave us with just 19. And that's the result that we want. All right. Any questions? All right. So the next one, we have square root of 1 over 81. I say 8 over 81. Square root of 1 over 80x. So here, I just broke it up, square root of 1 over the square root of 80x. All right. Then I went ahead and simplified the square root of 80x. And so that breakdown is down here. So I broke up the 80 into 16 times 5. Here's what I can take the square root of. Here's what I cannot take the square root of. You can't take the square root of x. And so take the square root of 16, that's 4, and leave the 5x under the radical. So that's how we got this situation right here. All right. So we still want to get that 5x, square root of 5x out of the denominator. So we multiply top and bottom by the square root of 5x. One times the square root of 5x is just the square root of 5x. On bottom, we have 4 times the square root of 5x squared. Take the square root of 5x squared, and that'll just be 5x. 4 times 5x will give me 20x. And that'll be your answer, square root of 5x over 20x. Don't forget this x on top is under the radical, so it cannot cancel out with the x down bottom. All right. Any questions? All right, scrolling up. So here we have the fourth root, and we're trying to get rid of the radical in our denominator once again. So we're taking the fourth root of both numerator and denominator. The fourth root of 16 is 2. That's because 2 times 2 times 2 times 2 is 16. Then we're looking at the fourth root of 27. We have to ask ourselves, what can we multiply to 27 to make it a perfect fourth root? Or and that would be 3, because if you look at 27, that's 3 times 3 times 3. That equals 27. So in other words, I have 3 3s that are in 27. So in order to make it a fourth power, I need to multiply by one more 3 to turn it into 81. So that's what I did right here. And so that'll give me the fourth root of 81 now. And also remember, whatever you do to the top, to the bottom, you have to do to the top as well. So that's why I have the fourth root of 3 in my numerator. So now I can take the fourth root of 81, which is 3, and leave that fourth root of 3 in the numerator with that too. Any questions? All right. All right, so the next piece, still flowing with the same type of stuff, but we have to get into conjugates. Conjugates is just changing the middle sign of your term. So if I have x plus y, conjugate would be x minus y. If I have 5a plus 7b, then 5a minus 7b would be the conjugate. Or if I had the square root of 17 minus 3m, the square root of 17 plus 3m would be a conjugate. So your conjugates is the same two terms, just that you're changing the middle sign. All right. Whenever you multiply conjugates, this is why this is important. Your middle terms are going to cancel. And we can use this thought process to rationalize denominators or numerators. You see how in a second. All right, so first one, we have 4 over 3 minus the square root of 11. So once again, the goal is to get rid of the presence of the radical. So we're going to do what I have in the purple. We're going to multiply the conjugate, multiply by the conjugate of your denominator, wherever your radical is, whatever you're trying to rationalize. Let me say it like that. Whatever you're trying to rationalize, you're going to multiply both top and bottom by the conjugate. So we're going to multiply top and bottom by 3 plus the square root of 11. All right. So take it one step at a time. Notice I got my in the green the multiplication of the numerator to the conjugate, then in blue the multiplication of the denominator by the conjugate. So in the numerator is just 4 times 3 plus the square root of 11. So 4 times 3 is 12. 4 times square root of 11 is just 4 square root of 11. So that is our going to be our new numerator. Then in our denominator, we're doing 3 minus the square root of 11 times 3 plus the square root of 11. So 3 times 3 is 9. 3 times the square root of 11 is 3 square root of 11. Negative square root of 11 times 3 is negative 3 square root of 11. And then negative square root of 11 times positive square root of 11 is negative square root of 121. Then notice our middle terms cancel. 3 square root of 11 cancels out with negative 3 square root of 11. And then square root of 121 is 11. So 9 minus 11 will give us negative 2 for our new denominator. All right. So notice the negative 2, whatever's in your denominator has to go into each numerator. So that's what I did here. That gives us 12 over negative 2 plus 4 square root of 11 over negative 2. And that'll be negative 6 minus 2 square root of 11. Questions? Any questions? All right. So if they ask you to rationalize the numerator, it's the same thought process, just that we're trying to remove the radical out of the numerator instead of the denominator. So just make sure you hold true to whatever direction they ask you. They say numerator, we're talking about top number. If they say denominator, you're talking about the bottom number. So here we have the square root of 3 over 17. That's square root of 3 over square root of 17. We want to get rid of the radical in our numerator. So we're going to multiply top and bottom by the square root of 3. So that'll be square root of 9 over square root of 51. Square root of 9 is 3. So it's 3 square root of 51. Any questions? All right. Next one, we have the cube root of 7 over 125. If I take the cube root of the top and bottom individually, I can take the cube root of 125, which is 5. So that simplifies to just 5. Then the cube root of 7, you say what times 7 will make it a perfect cube? So all we have is 1 7. That means we need 2 more 7s. That's what I was trying to emphasize here. So we need 2 more 7s. 7 times 7 is 49. So that's why we multiply top and bottom by the cube root of 49. Remember, in order for it to be a cube, a perfect cube, you have to have 3 of that number. If it's square, it has to have 2 of those numbers. You know, if it's fourth root, you need 4 of those numbers. All right, so we multiply top and bottom by the cube root of 49. 7 times 49 is cube root of 343, which simplifies to 7. Then in the bottom, 5 cube root of 49. Any problems, any questions? Scroll up. Still looking at rationalizing the denominator. This is our original problem, but the radical is in our numerator. So we're going to multiply top and bottom by the conjugate, 2 plus square root of 10. So once again, take your time, multiply, one segment at a time, multiply the numerator, and then multiply your denominator. So in the numerator, we have 2 minus square root of 10 times 2 plus square root of 10. So do your distribution, that'll be 4, 2 square root of 10 minus 2 square root of 10 minus square root of 100. 2 square root of 10 cancels in the middle. Square root of 100 is 10. 4 minus 10 is negative 7. Then in our denominator over here in the blue, distribute that negative 7 that's in the denominator. That'll be negative 14 minus 7 square root of 10. Any problems? All right. So let's finish it off. So we have -7. I mean, not -7, -6. That's our new numerator. Over -14 minus 7 over the square root of 10. And so what I was saying here is that this could be your answer, or if they don't want negatives, if you multiply top and bottom by -1, that will get rid of, the negative in each term. So either one of these could be the answer. What probably happened was somebody had a problem with it and asked about the positive. So that's why the answer wasn't right. So either one of those should be fine. But if by some chance, you have all those negatives like that, and they're not, it probably should give you some type of hint saying that, get rid of negative or something. I don't know why it would, but both of them equal to the same thing. But like I said, if you have to get rid of the negatives, you just multiply top and bottom by -1. That means each one of the signs have to change. And that's what we get here in that final result. Questions. All right. Problems, any problems, questions? Let's scroll up. Well, let's see how long this section is. 1, 2, 3. Not too bad. Hold on, 17.6. Okay, 17.7. All right, hold on 1 second before I forget. That's actually 17.7. So let's look at 17.6 as well, and then we'll be done for today. Oh, went up too far. All right, so 17.6 on radical equations, solving radical equations. So here are our steps. We want to isolate the radical if necessary. We're going to raise each side of the equation to the power of the index of the radical. Simplify. Step 3, if a radical still exists, we repeat steps 1 and 2. Step 4, solve. Step 5 should be checked. Give you a chance to write that down. All right, so let's do those steps. Everybody still copying? Let me know. Okay, let's look at the first one. You have the square root of x minus 20 equal to 7. So the first step is to isolate the radical. In other words, get the radical on one side by itself. It's already done for us, so step 1 wasn't necessary in this problem. The radical is already on one side of the equation by itself. It's already isolated. All right. Step 2, we're going to raise each side to the power of the index of the radical. So we have a square root. Excuse me. So we're going to square both sides. Square and square root will cancel on the left. Then on the right, 7 squared is 49. Step 3 was not necessary for us. It says if there's still a radical involved, you repeat steps 1 and 2. So there is not a radical involved. So step 3 was not necessary. Step 4, solve. We have 69. By adding 20 to both sides. Then we got to check, because when it comes to these type of problems, it is possible for your solution or solutions not to work. So you have to make sure you check them to be sure. That's because you're doing things like squaring both sides. That changes the dynamic of that equation, or it can change it anyway. Plugging in 69, 69 minus 20 is 49. Square root of 49 is 7. So that works out for us. All right, any problems before we look at another one? So if you follow those 5 steps, that will be how we will be able to solve and make sure we're good to go. So here, square root of 2x equal to negative 6. Once again, the first step is isolate your radical. We don't have to do it because it is isolated on one side of our equation. It is on one side of the equation by itself. So you take the square of both sides. So square root of 2x, where the square of 2x, the square root of 2x squared. There you go. We'll cancel out and just give you 2x. Negative 6 squared is 36. So negative 6 times negative 6 is 36. Then divide both sides by 2 will give you 18. Now you notice over here I did the check. You plug in 18. 2 times 18 is 36. Square root of 36 is 6. Notice 6 is not equal to negative 6. So that ends up x equal to 18 does not work for us. And that was our only solution. So since that does not work, that means there is no solution. So no solution is actually our answer. When you come down with a solution and you do everything correctly and it still does not work, that value is considered extraneous. That's what I wrote in the purple. X equal to 18 is an extraneous value. All right, any questions before we look at another one? Scroll up. All right, next one, square root of 4x minus 7 minus 3 equal to 0. So notice this time we have a minus 3 that's outside of the radical. We do not have this radical on one side of the equation by itself. So what we need to do first is add 3 to both sides. So this is one situation where step 1, was needed. We had to add 3 to both sides and isolate our radical. All right, so now we have the square root of 4x minus 7 equal to 3. Square both sides. Square and square root cancels, leave you with just 4x minus 7. And then 3 squared is 9. All right, so now we can go ahead and solve. Add 7 to both sides. 4x equals 16. Then 4x divided by 4 to cancel out the 4 in front of x. X is equal to 4. All right, any questions, any questions? So as always, you go ahead and check. 4 times 4, 16. Square root of 16 minus 7. It's 9. Square root of 9 is equal to 3. All right. So here we have the cube root of x minus 5 minus 4 equal to 0. So notice we have cube root this time, not square root. So steps going to be the same. It's just that instead of raising both sides to the second power, we're going to raise both sides to the third power. But other than that, the steps will be the same. So we're going to add 4 to both sides. Cube root of x minus 5 is equal to 4. Then we would cube both sides. All right, so the cube and the cube root cancels, leaving you with x minus 5 on the left. On the right, 4 cubed is 64. Add 5 to both sides. X is equal to 69. Once you get an x equal to 69, of course, you go ahead and check it, throw it back into your original problem. 69 minus 5 is 64. Take the cube root of that, that's 4. 4 minus 4 is 0, and that works out for us. All right. Very good. Kind of scroll up. Got a couple more scenarios and then we finish. So here we have the square root of 22 minus x equal to x minus 2. So we do have our radical isolated on one side of the equation. So we're okay with that. But then we have to take the square of both sides. We have the square root, so we need to square both sides to get rid of the radical. So we see the next line, the square and the square root cancel, leaving me with 22 minus x. Then on the right side, we have x minus 2 squared. So you see what I did here in the purple. I went ahead and folded that out and expanded it out to x squared minus 4x plus 4. All right, so now we have 22 minus x equal to x squared minus 4x plus 4. Notice in the red I wrote, we want to set one side equal to 0 because now we have this quadratic situation. So I brought that arrow. We have x squared, so we want to set one side equal to 0. So I subtracted 22 and added x to both sides. So that will give me x squared minus 3x minus 18 equal to 0. All right. So once you're here, you can go ahead and factor, or if you want to use the quadratic, when we haven't talked about the quadratic equation yet. So quadratic formula, we'll talk about that soon. But so right now we're looking at factoring. We have talked about that. So factor that out to x minus 6, x plus 3. Set each part equal to 0 and solve. So you add 6 to both sides, give me x equal to 6. Subtract 3 from both sides, give me x equal to negative 3. All right, everybody good? So just like before, we need to check, but we have 2 solutions to check this time. If I scroll up too far, let me know. So in the black, that was our original equation. So we plugging in 6 and negative 3 separately into the original equation. So on the left side, we see plugging in 6 that results in the correct answer, but plugging in negative 3 does not work out for us. So always make sure you hold true to those negative signs, because that's going to be the difference in what works and what doesn't. And so x equal to 6 is our only solution. Like you said, this one didn't work. Well, I wrote that too. So, all right, there we go. X equal to 6 is our solution. X equal to negative 3 is not a solution. That is extraneous. Remember, we talked about that already. So if they ask you what's the solution, you would just give, x equal to 3, x equal to 6. All right.
Sorry about that, Mr. Tuck. I ain't heard what the last thing you said. My daggone wash machine making a crazy sound today. Life, man.
It's all good, man. So, so what we did right here is this last little piece. We had to check our solutions, just like we did for everything that we've done up to this point. We have to check our solutions. This time we had 2 solutions. We had x equal to 6 and x equal to negative 3. So you check them individually. So over here, I took 6, plug it back into the original equation, and it ended up working out for us. And then over here, I took negative 3, plugged into the original equation, and that one didn't work out for us. And I was also emphasizing, make sure you hold true to these negatives. Be careful with them, because that's going to be the difference in whether something works out or not, or vice versa, whatever the case may be. So we saw 6 is a solution, negative 3 is not a solution. And so if MATLAB were to ask you what's the solution, all you would do is give the 6. You wouldn't give both of them, or it will mark it wrong. And so that was pretty much what I was saying as far as this piece is concerned. And EXT, extraneous, that was the term I used before. When you have a value that comes out to be a solution and it does not work, it's called extraneous.
Okay, thank you.
Yep, not a problem, sir. All right, everybody good? Can we scroll up? All right, so this next one might be the last one, but this next one is one we really got to make sure we pay attention to and watch out because of what we got over here in the purple. And so notice we have multiple or two different radical expressions or radicals in our expression, in our equation. So we're going to hold true to the same process, but part of the process is more involved than normally. So we're going to square both sides. We have one of our radicals isolated by itself on one side of the equation. So we're going to square both sides. That gets rid of the radical on the left, and that's going to leave us with just y plus 2. But then on the right, yeah, I might just have to slide over some. I will in a second. In the right, I have 4 minus the square root of y minus 16 squared. So I have to fold that out just like I would any other expression. So for you to see that. So we have 4 times 4, which gives me 16. And then we have 4 times negative square root of 6, the negative square root of y minus 16, which is this. Then distribute negative y minus 16 times 4 is this. And then negative square root of y minus 16 times negative square root of y minus 16 is this over here. So this is square root of y minus 16 squared. All right, so the result in that, we will go ahead and combine our like terms in this middle right here. So negative 4 square root of y minus 16 minus 4 square root of y minus 16 will give you negative 8 square root of y minus 16. Then over here, the square and square root will cancel, leaving you with just y minus 16. From there, combine your like terms. We have 16 and negative 16. They cancel. And that leaves us with just negative 8 square root of y minus 16 plus y. And so that's how we get that over here. So before we go any further, make sure we're okay with this purple. And then I'll slide back over to the left. All right, is everybody done with this purple? Can I scroll to the left? Are you okay? All right, so now we're here. Y plus 2 equal to y minus 8 square root of 16. But if I can get this eraser to, no, it's not erasing. All right, there we go. But we still have this radical here, so we need to get rid of that. And that goes back to steps 1 and 2. You want to isolate the radical. So you subtract y from both sides. And notice that y's end up canceling on both sides. And that leaves me with 2 equal to negative square root of y minus 16. So notice what happens here when we square both sides to get rid of this radical. 2 squared gives me 4, but when I square this, I have to multiply it to this 8 and to this radical here. So make sure you multiply it to both. So the square root of negative 8 squared is 64. And then the square root of y minus 16 squared cancels out the square root, and that's just 64 times y minus 16. All right. You can distribute the 64. 4 is equal to 64, y minus 1024. Divide both sides by 64. So that's 1028. I added 1024. I don't think I mentioned that. So you add 1028. Oh, add 1024 to both sides. And that'll give me 1028 equal to 64y. Then we divide both sides by 64. Gives me 1028 divided by 64. Simplified it because 4 could divide into both. That leaves me 257 over 16. Any problems? All right, so, we always check. So when you plug the value in to check, the value will not work for you. And, we had done enough checking. I was just, going through the process. That's why I didn't go through this one. But yeah, when you plug the value in, it will not work for you. And since it is our only option as an answer, that means our answer is going to be no solution. Got one more scenario to show you, and then we'll be done. Questions? Any questions?
Sir.
All right. There we go. We're scrolling up. If I'm not mistaken, this is the last one. Yep, the last one for today. All right. So I want to find the length of the unknown side, of the triangle. So they give us this diagram over here. So we have 12 feet and 3 feet. And you want to know what's the side of the missing side. Right here. So whenever you have a right triangle, you can use the Pythagorean theorem in order to figure out your sides. If you have 2 out of the 3. So, we have a squared plus b squared equal to c squared. A and B are pretty much interchangeable. You can use them in either order, but C has to be the one on the side by itself. That's your hypotenuse. A and B are just considered legs. C is your hypotenuse. That's the one opposite the right angle. That's the one opposite the right angle. That's always your C, always on one side by itself. All right, so if we plug in accordingly, You know, this can be A, this will be B, and then the missing side is C. So that's 12 squared plus 3 squared equal to x squared. 12 squared is 144, 3 squared is 9. Add those together, that's 153. Take the square root of both sides. So don't forget the square root property. Whenever you take the square root of both sides, you do plus or minus. But notice my message in the purple. Because we are dealing with measurement, the negative answer is not a valid answer. So we wouldn't use like that. Oh no. All right. All right. So negative is not useful when you talk about measurement. We don't use negative measurements. So we're just going to use the positive. Then I ended up breaking up the 153 into 9 times 17, took the square root of 9, which is 3, left the 17 under the radical. And so that is the most simplified way of expressing the answer. If they ask you for decimal, then all you had to do was do the square root of 153 in the calculator. But you know, just pay attention to whatever Math Lab asks of you. All right, questions? Any questions? Any problems? Any concerns? All right. So everybody done copying this while I switch to the next screen? All right. So just want to show you guys this. Just once again, just emphasizing where we are in the class. We did 17.5 and 17.6 today. Next class, we'll just do 17.7, complex numbers. And then that'll be it as far as new material for chapter 17. And then from there, we'll look at sections 1 to 18, 1, 18.2, and 18.6 as our last set of new material. From that point forward, you know, like I said, we'll just be in the process of reviewing. You guys will come to class, ask whatever questions you want to ask. If we, you know, even set up some of our class periods for test taking and stuff like that. But the new material will be done. We'll have 4 more sections of new material left: 17.7, 18.1, 18.2, and 18.6. All right. Questions on anything? Make sure we're good. All right. So if you guys are good, I'm good. Have a great weekend. Be safe. And we're on countdown time now, guys. So make sure you're taking advantage of the time that you have. And let's get caught up for those who aren't caught up and those who are on task. Continue the great work. Let's make it happen. Let's close out the class. All right, y'all take care.
Have a great weekend.
Thanks, do the same.
All right, Mr. Tuck, I'll see you in the morning.
Yes, sir.
All right.